Problem number 2101. Detonate the maximum bombs. You are given a list of bombs. The range of a bomb is defined as the area where its effect can be felt. This area is in the shape of a circle with the center as the location of the bomb. The bombs are represented by a zero index to the array bombs, where bombs I equals xi, yi, ri. Xi and yi denote the x coordinate and y coordinate of the location of the ith bomb, whereas ri denotes the radius of its range. You may choose to detonate a single bomb. When the bomb is detonated, it will detonate all bombs that lie in its range. These bombs will further detonate the bombs that lie in their ranges. Given the list of bombs, return the maximum number of bombs that can be detonated if you are allowed to detonate only one bomb. Okay, so the first question I want to ask is, what does it mean by detonate all bombs that lie in its range? What did it mean by lies in its range? Is that the bomb's location? So like the center of the range, is that the xy coordinate of the bomb that is in the circle? Yeah, like so if 0, 3, bomb 1, bomb 1 and 2. Okay, so outside the range. Okay, so the location outside the range will not be detonated. Okay, so xy is the coordinate. Okay, so like if so if two bombs, okay, if bomb I can detonate bomb J, then that means that means xi minus xj plus yi minus yj I think it's like yeah, it's a distance thing. Will equal will be smaller or equal than Ri with the power of 2. So, like the most stupid way will be loop through all the bombs and yeah, check. Yeah, like brute force. Will be loop through yeah, like yeah, loop through bombs and check, yeah, so see which bomb can be detonated by the current bomb. And yeah, it's like a recursion problem. So if bomb I can detonate bomb J, then you can see bomb J. Yeah, you can check whether like which bombs can be detonated by bomb J. Okay, so I think I will use a DFS approach. And I'm thinking yeah, I think I need to calculate first all the bombs yeah, the distance between all the bombs, and it will be easier for me to check which bomb can be detonated by the other. So yeah, okay, so the time complexity will be yeah, like if okay, we need to return the maximum number of bombs that can be detonated. So yeah, the brute force will be go through every bomb and see see which bomb, yeah, and calculate the bombs. Okay, yeah, that means calculate the bombs that it can reach and see which bomb has the maximum. Time complexity will be big O. I think first of all we will have to build a distance list. Yeah, so that will be now we have to select each two bombs and calculate its, I think it will be, yeah, and with the power of 2, and then plus we have to loop through the bomb list, and that will be and yeah, for each DFS you will for each DFS you will find all the bombs that the I's bomb can reach. And yeah, that will be and plus that will be n plus n. Yeah, since okay, maybe okay, so since I think we will okay, I'm not sure with the DFS, but the most, yeah, we will have, and since the building a graph, building a matrix of all the bombs distance, we need n with the power of 2. So yeah, we will have, and for DFS I don't think it will override. Yeah, it will be larger than n with the power of 2. So yeah. And then okay, so n is 100. So okay, it's fine. Then we will have let me think, maybe a matrix, like bomb I and bomb okay, so we will have a matrix and we will calculate this distance. Let's call it distance, and we will have 0 multiplied by, we'll have length n as the length of bombs. And for I in range n, and for j in range n. Okay, so yeah, I will be the bombs I and bombs j. So let's calculate its distance. Or maybe we can, yeah, we can, not distance, but we can say if bombs I is, yeah, like whether bombs I is in bombs j range. So yeah, we'll have bombs I, that is bombs whether bomb I, okay, bomb I equal, I'll say, okay, xi, yi, and the range. And xj, yj, rj equals bombs j. Okay, so if x, okay, let's have this if this is smaller than or equal to what's the range? And so this means this means xi I Okay, this means bomb I can detonate bomb J. That means bomb J is in the range or maybe let's change. This we can say this is detonate. Okay, so whether bomb I can detonate bomb J. Okay, so if this, then detonate IJ will be 1. And okay, so then if we'll have to do the opposite, so we will have xj minus xi yj minus yi and rj. So that means bomb I is in the range of bomb J. Then we can detonate. Then like exploding bomb J can detonate bomb I. So okay, so now we will move on to for loop the bombs. For loop the bombs and see each. And try to find the maximum connected bomb with bomb I. We will for loop every one. But we will use a visited set and skip the ones that is already in the visited set. So and we will for loop the we will try to find each bomb, the size of the connected bombs of each bombs. So okay, so maximum bombs equals 0. Okay, first of all, we will have if I not in visited, then we will have DFS I. And Detonate size. Let's have size. Okay, so every time the size should be reset. And okay, if size is larger than max bombs, yeah, then update the max bombs, and then return the answer max bombs. And we'll have our DFS. So DFS I will be find all the bombs that bombs I can reach. So okay, so we will set it to visited. I will add it to the visited set, and for the bomb in detonated I, if we will enumerate. So we will have bound and is connected. If is connected and not in visited set, bound then we will have DFS I. Now we will go dive deep. Oh, sorry, bombs. DFS bomb. And yeah, and here we will add size. We need non-local size. Yeah, kind of like. Yeah, like calculate every bomb's size and see who is the maximum, who can detonate the maximum bomb. I think, yeah, maybe we can dry run, like, yeah, let's dry run this. Oh, let's see if we have edge cases. Okay, this maybe, yeah, we can try this, like, okay, so we will have detonate, yeah, we have 2 bombs, and it will be one. Yeah, it will be, yeah, itself 0. A bomb 0 can detonate bomb 0. So yeah, it will be 1 for itself, and then 1 with 0, 0 with 1, bomb 0 with bomb 1. Bomb 0 is this green one, and bomb 1. So can bomb 0 detonate bomb 1? Now, so it's 0, and it can bomb 1 detonate bomb 0. Yes, so it is 1, and it can detonate itself. Okay, so we have this detonate matrix, and then we will move on to the for loop. So for I in range n is 2, we have I equals 0, and we have DFS 0, since it is not in the visited set. So visited set will add 1, add 0, and size will be added to 1, and for bomb, detonate 0 is 1, 0 and 1. Bomb is 0, but bomb is already in the visited set. Let's see, the next one will be bomb is 1, connected is 0, so it will not enter. So size is 1. Okay, so this will be updated to 1. And okay, the next one will be, okay, I will be equal to 1, and then 1 is not in the visited set, so we will have DFS1, and we will add it to the visited set, and size will be added to 1. Okay, so for 1, 0, 1, 0, so bomb 0, is connected this is I is 1, so 1, bomb 0 is connected, yes, but 0 is already in the visited set, so we will not go into 0. Wait, yeah, we should add, the size should be added to 2, but or like maybe size I'm thinking maybe move size to here, so that it will check if connected, then we can add it by 1, so we don't have to actually dive in. Okay, so I found it is actually a directed graph. Yeah, so like for example, for this example 1, bomb 0 cannot detonate bomb 1, but bomb 1 can detonate bomb 0. So yeah, it is a directed graph. So I'm thinking of changing this matrix to maybe like a dictionary, or yeah, the key will be the bomb and the value will be a list that keep track of the detonated bomb of bomb I. So maybe I will do it like I'll have this, and okay, so if I equals j, then continue. So we can have I will append j, and j will append I. Okay, and then I found, so through the gyron, I think we cannot use a global visited. Yeah, we should reset the visited set every time we start a DFS. So yeah, it will be like like this, and and for this we will change it to 4 bombs in detonate I. If bomb not in visited, then we will have DFS bomb. Okay, so let's try run again. We will have, for this we will have, first of all, like this, and to build the graph, we will have 0 with an empty array, and 1 with 0. So then we will start our for loop. So I will be 0 first. So for DFS I will add the visited set to 0, and size will be 1, and for bombed in, okay, we will not run this since it is an empty array. So we'll return, and we have now we have size 1. It is larger than the 0, so we'll have max bounds now 1, and then we'll have I equals to 1, and we'll reset this. Okay, so for DFS I, we will add 1 into the set. And for bombs in detonated 1, it is 0. So for bomb 0, it is not in the visited set, so we will dive into. I is 1, so we'll add, I is 0, so we will add 0 to the visited set. Size will be added by 1 again, so it's 2 now. Okay, and there is no more for detonated I, which is 0, so we will return and then finish the DFS. So size is larger than max bomb, yes, so this will be updated to 2. So we will have max bombs, 2, so we'll return 2, correct. And let's see the other example that the bombs are all isolated, so we will have 2 empty arrays. So for this, we'll reset. We will start our I from 0. N is 2, I is 0. So for 0, we will add it to the visited set. Size will be added by 1. And since it is an empty array, we will not. So since it is an empty array, we will not run into this for loop. So it's done. Then we will have size 1 updated to max bombs. Then we will have I equals to 1. Okay, so this will be reset, this will reset. So for I is 1, we will add 1 to the visited set. Size will be added by 1. And since it is an empty array, we will not run the for loop. So we will finish the DFS, and size is not larger than max bombs now. So we will not update and return 1. Okay. Let's see. It's typo. Okay.